Okay, so we're gonna solve a problem here where we got an axis and we got three balls at three different radiuses with three different masses, and they are rotating at a rotational speed of 2 radians per second. So we are asked, the first question is, what is their inertia? All right. So to calculate their inertia, we know that the inertia equals the sum of the mass times the radius squared. All right. So this is the inertia right here. And since we got three masses and three radiuses, all we have to do is do the inertia equals 4 kilograms times 3 squared plus 2 kilograms times minus 2 squared plus 3 kilograms times minus 4 squared, right? And this is how we get it, and we get an inertia of 96 kilograms times square meter. There we go, 96. That's our first result, alright? So the next thing we have to calculate is the following. We have to calculate the kinetic energy of the whole system. And in order to do this, we have two ways of doing it. The first one would be by this formula that says that the kinetic energy equals the inertia times the angular rotational velocity, alright? So that means, rotational velocity squared. So that means that the kinetic energy equals 96, which we obtained earlier, times 2, and K equals 182. There we go. So that's the first, the way to obtain the kinetic energy. And now we're going to do it in a second way. The second way that we have it is by using the traditional sum of kinetic energies, which is 1/2 of mass times velocity squared, right here. And we know we can do this because we know that the velocity equals the radius times the rotational velocity. So if we know this, we can substitute. We can work the velocity out of here, and then we know that we can calculate the velocity for each one of these, and then we can simply sum all of these, and then if we sum m1 times v1 plus m2 times v2 squared plus m3 times v3 squared, this should equal 182 in kinetic energy. And that's how you solve the problem. Thank you.